The volume of a sample of pure HCl gas was 180 ml at 25 degrees Celsius and 110 mmHg. It was completely dissolved in about 50 ml of water and titrated with an NaOH solution. 16 ml of the NaOH solution were required to neutralize the HCl. Calculate the molarity of the NaOH solution. Okay, so let's answer this problem step by step. So let's focus first on the first sentence. According to the first sentence, the volume of the pure HCl gas was 180 ml. The temperature is 25 degrees Celsius, and the pressure is 110 mmHg. So we're given the volume, the temperature, and the pressure. So we can use the ideal gas equation, which we all know that's PV equals nRT. So since the pressure, volume, and temperature are already given, what's missing is the number of moles, or N. So to solve for N, what you do is divide both sides of the equation by RT. So RT cancels on the right side. So to solve for N, that is PV over RT. Now let's substitute the values. The pressure according to the problem is 110 mmHg, but we need to convert that first into ATM. So how do you convert 110 mmHg to ATM? We know that 1 ATM is equivalent to 760 mmHg. So the mmHg cancels out. So 110 divided by 760, that's approximately equal to 0.145 ATM. Okay, so you plug that value, 0.145 ATM. The volume, according to the problem, is 180 ml, but first you need to convert that to liters. So what's the conversion? 1 liter is 1,000 ml. So ml would cancel out. So 180 divided by 1,000, that's equal to 0.180 liters. Then you put that value into our formula. R is the gas constant, which you should have memorized by now. The value is 0.0821 liter atmosphere per mole Kelvin. And the temperature, according to the problem, is 25 degrees Celsius. But remember, in ideal gas law, the temperature must be in Kelvin. So how do you convert Celsius to Kelvin? You simply add 273.15. So in this question, the given is 25 degrees Celsius. You just add 273.15, and that is equal to 298.15 Kelvin. So that's our temperature. So as you can see, the ATMs would cancel, the liters would cancel, the kelvins would cancel, so our remaining unit is moles. And if you solve this in your calculator, 0.145 times 0.180 divided by 0.0821 times 298.15, this will give you approximately 0.00107 moles of HCl. Okay. So now that you have the moles of HCl, let's proceed to the next part of the problem. It says here that HCl was neutralized by an NaOH solution. So that means a reaction happened between HCl and NaOH. And we know that HCl is an acid and NaOH is a base. So it's an acid-base reaction. So it's important for us to write the reaction between HCl and NaOH. So an acid plus a base forms a salt. So the salt that forms here is sodium chloride and the other product is water. Okay, so this is the reaction between HCl and NaOH. And as you can see from the reaction, what is the ratio between HCl and NaOH? So for every 1 HCl, it reacts with 1 mole of NaOH. So the mole ratio is 1:1. So how do we apply that to this problem? So remember, we have solved 0.00107 moles of HCl, right? And then we plug in the molar ratio. 1 mole of HCl is equivalent to 1 mole of NaOH. And that is equal to 0.00107 moles of NaOH. So since the ratio is 1:1, that means whatever is your moles of HCl, it's the same as your moles of NaOH. So now that we have the moles of NaOH, the problem says calculate the molarity of the NaOH solution. So if you can recall, what's the formula for molarity? Molarity is moles per liter. So in the problem, our moles of NaOH is 0.00107 moles divided by, if you read the problem, it says here that the volume of the NaOH solution is 16 ml. But first, we need to convert that to liters. So 16 ml. Again, 1 liter is 1,000 ml. So ml would cancel. That is equal to 0.016 liters. So you plug that into our equation for molarity. So we have now 0.00107 divided by 0.016, and that is approximately equal to 0.0669, and the unit is moles per liter, or 0.0669. We know that moles per liter is also known as molar, capital M. So the answer is 0.0669.